back.
64.
Yes.
So Lois, this is just like the first one.
How?
I don't know. I was excited about this one like the first one. 64 is disjoint events.
All right. So, disjoint events.
Okay, this is an important vocabulary word. Two events are disjoint if they don't have any outcomes in common. So if we're talking about the rolling two dice, two events are disjoint if they don't have any die rolls in common. So we got two events here. Event A is the event that the first die is a 1. So first die is the red die, and that would be that first row in the table. And maybe label it A. All right, event B is at the, I should say, second die. Oh, first die is a 5.
It's a 5.
All right. There we go.
Right there.
Now, these are disjoint events. They don't have any intersection.
Right.
So there's no outcome that's in both A and B. So that's what it means to be disjoint. And that's a word, an important word. And another important word we're going to come up to is independent in a couple of days. Disjoint. Now, we want to find the probability of A union B. So there are 36 die rolls. So the probability of A union B
would be...
We could break this up. It's the number of dice that are in A.
Well, there's 6 here, and there's 6 here, so it'd be 12 out of the 36. Or 2, 6, 1/3.
2 6, yeah. This is 1/3. So one thing we notice is that the probability of A is 1/6, and the probability of B is 1/6, and 1/6 plus 1/6 is 2/6, which is 1/3.
Yes.
Okay, so when they're disjoint, you can just add the probabilities.
Right.
All right, hit this line. So this is one of the probability laws. It's like part of it. When two events are disjoint, the probability of the union is equal to P of A plus P of B. All right. Okay, so let's see another example of this. All right, so event A, we have cards. We're going to deal one at random. Event A is the event we get an ace.
So do the aces right here. A for ace.
Yeah, and B is for face card.
B is for face card.
Somehow. So B is the event, they got face cards. So again, these are disjoint events. There's no card that's both an ace and a face card. Right, so totally separate. Disjoint means like separated. Okay, so we want to find the probability of A. And we're going to leave it, let's leave it so it's not reduced, because I think we can see the math better.
Okay.
So it would be 4 out of 52. What's the probability of B?
For B would be 12 out of 52.
Okay, now the union is what we get when we combine those. So we have 4 aces and 12 face cards, so it'd just be 16 out of 52. So what we notice is what we were talking about. When they're disjoint events, the probability of the union is just the probability of A plus the probability of B. So maybe we can write that, 16 over 52.
What?
Yeah, so let's just copy it. 16 over 52, that's the probability of the union, equals 4 out of 52 plus 12 out of 52. All right, the problem is when we double count. So we'll get to that in a second.
Right.
But if they're disjoint, we can just add their probabilities.
Yeah, there's no double counting.
Okay.
All right.
So we have 2 dice again. Event A is the first die is a 1. So that's the same thing we had before.
Yeah.
Okay, let's label that A.
Okay.
And this time, our event B is that the second die is a 1. And that would be the first column. This time, they're not disjoint.
Nope.
So let's see if this statement's true. There's probably A union B. There are, I count, 11 in A union B.
Okay.
You agree?
I do.
And we want to know, so put a question mark over that equals. So we want to know, is that the same thing as if we add probability A plus probability B? It's actually out of 36, I'm sorry. 11 out of 36.
Yeah, we're doing cards. I mean, I'm still on card land. Let's do this.
So 11 out of 36.
11 out of 36.
Equals with a question mark.
Thank you.
Can we just add the probabilities this time? So the probability A is 6 out of 36. and B is 6 out of 36. And we see that this is no longer true.
Yeah, they are not equal.
Why is it not true, Mr. Lewis?
Well, because 6 plus 6 is 12.
Yeah.
And so that would be 1/3, or yeah, 1/3, whereas this is only 11 out of 36.
True. And what I'm getting
Slightly
at
less.
is
It's not true because, yeah, we share this
we
guy here.
counted
double.
that card twice.
Right.
So we got to fix this rule. So the way we could fix it is, right, could you write this, Mr. Lewis, the probability of A union B?
Or we could just go to the next slide.
We'll fix it first. Probability of A union B. We can add the two probabilities, so it's probability of A plus the probability of B. So right there, we know that this is double counting, so what we can do is just subtract that 1 that's in both.
Right.
So we're going to subtract the probability of A intersect B, what's in both. Because whatever's in the intersection, there's only one outcome this time, but however many that's in the intersection get double counted.
Right.
And then, so this is a fix. And we've come up with profound probability law. So when two events are not disjoint, this is a law. Put a big circle around this. This is something we're going to have to know. And sometimes this is called the general addition rule. That's for unions. All right, so there are no conditions on A and B. Whatever events A and B we have, add the probability of A plus probability of B, subtract the probability of the intersection.
Right.
All right, so there are 3 laws of probability. This is actually the second one. We can't skip to the second one. Okay. All right, here we go. So this time cards. A's event, we get a heart.
And that would be 13 out of 52.
Good.
We won't simplify it yet.
And
those are all the hearts.
B is probability, we get a face card. So that's a 12 out of 52. And if you combine those, there are 3 cards that we double counted.
Yes.
So we could say, let's write this as 13 out of 52 plus 12 out of 52 over here. So I know we could just count the cards, but we're seeing how this rule works. But we have to subtract the 3 cards we double counted.
So we had the 3 out of 52 that were the intersection. So really it's 22 out of 52.
Cool. And so we see it's the probability of A plus the probability of B minus the probability of the intersection.
Right.
Okay. All right. So if you actually count them, the ones we circled, there are 22 cards in the loop. All right. It's journal time.
Yes, it is.
So, boy, we didn't think about something, Mr. Lewis.
What was that?
Oh, they can kind of draw it on their phone.
What?
Oh, they don't have to circle it.
Yeah,
So
you don't have to circle it.
all right. All right. So A is the event. We get 4 through 6. Maybe just circle it for them so they can see it on here. They're doing this in the journal. There are a couple that are really good students might copy all that, but I hope not. And then event B is get a spade, so maybe circle the spades. And event C is you get an ace. Okay, we just have 2 probabilities for you to find. Now, right now, I don't care if you just use the diagram to figure those out, or you might want to try the new general addition rule that we talked about. Okay? Have fun.
All right.